Hey guys, welcome to Colored News. Now in this video we're going to take a look at generators. Now we all know what a generator is. We all see them being used, especially in areas where electricity is not stable. So we know them as those noisy machines that when you put on you can't even hear your next neighbor, and the problem is they are so noisy, they bring out very dirty smoke, but they are still very useful. So they help us generate electricity. So we're going to look at how generators actually work. Now, the basis of a generator is what we're seeing on screen. So this is just like it's kind of the setup that you need to generate electricity from a mechanical energy. Now, mechanical energy, that is why you always have to pull up a rope, or I don't know, a trigger. You have to do some sort of work with your generator set at home because it needs a mechanical energy to start working. So we're gonna take a very deep dive into how everything works, right? Now, this is my settings. With this setting, I have a means or a way of getting my mechanical energy. So with this tab here, so here is represented as like water flow, just like you have in your maybe your dam or whatever. So but this is my source of mechanical energy because you need mechanical energy to spin the bar magnet, the magnetic field. So you need the mechanical energy for that. So just this setup can be different in whatever project that you have, but this is just the basis. So practically to make a generator, you need you need magnets that will create the magnetic field. Then you need a coil, or we can say you need a wire or a cable that conducts electricity. All right, and that cable or that wire coil, whatever you want to call it, must be in a, I would say, in a winding form. Like you have to wind them, you have to make it in a circular form. Okay, you have to make it in a circular form. If this your cable, if your coil is straight, you cannot get the desired result. So the purpose why that we have the coil to be like in the circular form is for concentration of the electric field. For us to be able to concentrate the electric field in one small area. So that is the purpose why this winding is very important. So to make a generator, you need is a mechanical energy source. You need magnets, okay, that will create the electric field, the magnetic field, and you need cables or wires that will create your electric field, which, which in turn will definitely create your current later. All right, so now one thing that is very important is that your wire must be of good quality because it is through this wire that the electrons are going to flow, and when electrons flow, electricity is generated. In my previous video, I have talked about electrons and how useful they are in an atom. So it is an electron that generates electricity. And another thing you must know that before we start our simulation, our electrons represented by these blue circles, whatever, they are stable. Okay, so when electrons are stable, electricity cannot be generated. But it is when they start moving that electricity will be generated. And in your cable or your wire, whatever, you don't see electrons with your naked eye because electrons are found in the atoms of matter, like in the atoms of objects. And the naked eye cannot see the atom. And what is an atom? The smallest part of anything on earth that has chemical property, right? So the deal is your electrons must be able to move. You must look for a way to move electrons to create electricity. And the only way, which not the only way, but the substantive way that the world has used for like 100 years now, is using magnetic field. So when we start a simulation, we can increase our magnetic field with this bar here. Okay, so you can see that if I decrease it, the magnetic field will go away, and I can increase the magnetic field. Now, how do you increase the magnetic field? You increase the magnetic field by or using a bigger magnet or using a magnet of great quality. Okay, so I can choose not to visualize my magnet field. I can also choose to visualize. Then I need an indicator. What will indicate to me that electricity is present? I need an indicator. So I can either use this indicator or I can use my light bulb. But light bulb is what we really understand. So I prefer to use the light bulb. Then I can increase my coil. Now you must know that the more coil you have, the better the chance of creating electricity. Okay, if you have fewer coil, you have a minor, like a lesser number or lesser amount of electricity. That's the right word. But if you have more, you have greater amount of electricity. Okay, so I can also increase my loop area. I want it to be like 100%, so I can reduce it to whatever size I want. This is just simulation. I can choose to visualize my electrons. I can choose not to visualize my electrons also. My compass also, which is the direction of the feed, I can choose to visualize or not, and my feed meter. Okay, so I can also decide to visualize my feed meter. Now let's go straight into the simulation. Now I understand this is my mechanical energy. So if I release my mechanical energy, a very small amount of mechanical energy, that will spin my wheel slowly, and in turn that is going to move the electrons slowly across my coil winding, and that will proportionally generate a small amount of energy for me. Okay, you can see that on the light bulb we are seeing energy, but in a very small amount. So what can we already conclude? We can conclude that your magnetic field is directly proportional to your electric field. The bigger magnetic field you have, the bigger electric field you have. All right, so that is one thing we can already conclude. Now we can also conclude that the amount of mechanical energy that you put in is also directly proportional to the amount of magnetic field that you are able to generate with your mechanical energy. So that translates to the fact that if I increase my mechanical energy, my wheel is going to spin faster. Okay, so my magnet is going to spin faster, and I'm going to have better energy production. And the more I increase my mechanical energy, the faster it spins and the better electricity I generate. Okay, now one thing you must know that you can see the direction of my bar magnet: north, south, north, south, north, south. So this spinning is what, let me use the word, disturbs the magnetic field around these bar magnets. Okay, and you can see how the magnetic field turns as my wheel turns. So it is the proximity between the magnetic field and this electric field that will make the electrons on my cable or on my wire coil to want to move. So the proximity is what we want to make them to move, and the fact that electrons are moving, then electricity will be generated. The person that invented electricity for me is a genius. Like, that was unthinkable. So this is what we have to do today. We have learned that I can generate electricity if I apply a mechanical energy into a magnetic field, and if I have my coil close to my magnetic field, I can move my electrons on my coil, and in turn, I can have the desired amount of electricity. So I hope this class was clear, simple, and precise.